Satya's software channel presents the second video on software testing. Principles of software testing. There are 7 principles of software testing and they are found by the father of software testing, Mice. Today we shall see the 7 principles of software testing. Before we go into the principles of the software testing, let us see what is the intent of software testing. The intent of the software testing is to find the maximum number of bugs and errors in the software. The developer develops the software, the tester tests the software with creativity and reasoning to make sure that the defects in the software are found to the maximum extent. The intent of the software company is to give maximum defect-free software to the end user or the client. The software testers make sure that they find more and more bugs and they get them fixed and again retest them and ensure that they are working fine and then deliver the product to the end user or the client. The intention here is to ensure that high quality product is given to the client. Quality is directly proportional to the reputation of the company. If the quality is bad, the reputation of the company is lost. Not only that, it takes a lot of time and money and effort to fix the bugs at a later stage. If they are found while testing, it takes lesser amount of time, effort and money to fix them. So, quality is very important and software testing is very important. Now, let us see the principles of software testing. Principle number 1. Testing shows presence of defects. The testing is done with an intention of finding defects or showing defects. So, we know that testing is done with an intention of finding defects. So, how do we find defects? We have to write negative test cases to the maximum possible extent to find out the defects. Before we see what is negative testing, let us see what is positive testing. Example, let us take a login application. It has login, password and submit button. If you give the correct login, correct password and click on the submit button, it goes inside the screen. This is positive testing and this is a positive test case. In case of positive testing, we are giving valid data. Now, let us take the case of negative testing. Negative testing is creating and validating an application against invalid data. Checking if errors are shown as expected or not. Why is negative testing done? When negative testing is done, more and more defects and bugs are found. So we write negative test cases apart from the positive test cases in the test plan. Now let us take an example of login screen. It has email address, password and then the login button. Enter email ID and click on the login without giving the password. This is one of the negative test case in negative testing. It should show up an error, incorrect password. Now, the second scenario in negative testing. Enter the password and click on login without giving the email address. It should show a message, enter the email address. The error message should be shown. Now, let us take the third scenario. Enter an invalid email address and enter the password and click on the login. It should display an error message saying that invalid email address. In the first software testing principle, we have to ensure that positive and negative test cases are covered and testing is done with an intention of finding more bugs and defects. Testers have to use their creativity while testing. The second principle of software testing, exhaustive testing is impossible. So what does this mean? It means that including all elements or aspects is not possible while testing. For example, Let us take an application wherein we can enter a quantity from 0 to 100 million. Imagine, is it possible to test with so many values? 100 million values? Absolutely no. So, exhaustive testing is impossible. Covering every aspect of the functionality with all possible valid inputs and invalid inputs is exhaustive testing. Let us take an example. In the SPF document or the spec, there is a price value. The price value ranges from 1 to 100 million. So, we need to do two test cases. We have seen, right? One is positive testing and other is negative testing. For the positive testing, we will select some values randomly in between from 1 to 100 million, including 1 and 100 million, because the start and the end values are mandatory. Now, we will also include cases with negative values and 0 and ensure that when invalid input is given, error message is shown. This is a small example. Imagine an application having 10 or 12 such fields. Is it possible to test every value? Never. So, exhaustive testing of a software is not possible. We will try to find out maximum number of cases to ensure the coverage uniformly. We will take one value in units place, the other value in tens place, the other in hundreds, the other in thousands, some values in 10,000s place, lakh place, then millions. Between million and 100 million, we'll just randomly input some values. It will be 5 or 6 values. So we will test it in such a way that all the cases are covered to the maximum extent possible. We can't test every single value. For this, prime amount of testing should be done to ensure the risk. Because risk factor is involved, all areas should be covered. Nothing should be left or ignored. So how do we proceed the order? We first prioritize based on the high risk areas. So the high risk things are tested first, and then we come to the average risk and low risk cases and then test them. Exhaustive testing is not possible, and what we can do is we can prioritize and do the testing. Testers use their creativity and prioritize the test cases which need to be tested first and then follow an order while testing. Testing needs a lot of creativity and testing is not an easy job. Writing test cases effectively for testing also involves a lot of logic. Principle number 3, early testing. Testing should start as early as possible in software development life cycle. If defects are found in the analysis phase, the cost is less. If they are found in the design phase, the cost is more than the analysis phase. And if they are found in the coding stage, the cost increases than the design phase. And if they are found in the testing phase, the cost increases more than the coding phase. And if they are found in the maintenance phase, the cost increases furthermore. Early testing reduces the cost of fixing the defects. This is how the cost would increase phase by phase. In analysis phase, the cost is low to fix a defect. When it comes to the maintenance phase, to fix a defect, it's very expensive. You can see how high the costs vary from analysis, design, coding, testing, and maintenance phases. Principle 4, defect clustering. Defect clustering mentions that small modules or functionalities have most of the defects detected in them. Concentrating more on these modules or functionalities finds risky defects. So, to identify risks, Smaller functionalities have more number of defects. As per the Pareto principle, around 80% of the defects are found in 20% of the modules or functionalities. The small functionalities have 80% of the defects. That's what it tells. Principle 5. Pesticide paradox. In general, we observe that if the same pesticide is used to kill the pest develops resistance to the pesticide and will not die. For this, other pesticides have to be used and routine pesticides should not be used. The same rule applies here for testing. Testers should not only depend on the existing test techniques. They should use new methods and techniques for testing. Testers should be very creative and innovative in using the new techniques and methods to find hidden bugs in the software, application, or product. Testers should make continuous efforts to improve the existing methods and techniques and to make the testing more effective, to find more bugs. For these, the test cases need to be reviewed regularly, revised regularly. We have to add new test cases and changing the existing test cases. By following these, we can find more defects and bugs in the software application. Principle 6. Testing is context dependent. Appropriate testing approach should be based on the type of application. There are many types of applications: desktop applications, web-based applications, standalone applications. So, depending upon the type of application, the testing approach should be selected. In test automation, if it's a standalone application, QTP is in general used. And if it is a web-based application, Selenium is used. Principle 7. Absence of errors is a fallacy. With intense efforts also, 100% defect-free software application is impossible. Defects may be there. Maximum defect-free product can be ensured to the end user or the client, but the software does not assure that it is 100% defect-free product. Errors might be present in the product. Testing is not only finding the errors, it's also ensuring that the software meets the requirement and the client needs. We have to ensure that the requirements are as expected by the client. In our first video, we have seen how the client asks us and how we design something to the client. So it should not be like that. Whatever the client's requirement is, it should satisfy the client's requirement. Thanks for watching the video. Please leave your valuable comments and likes. Click on the bell button for notifications.